Welcome, Hornets, and thank you for joining me today. Today we're going to be talking a little bit more on solving trigonometric functions from 0 to 2 pi or between 0 and 360 degrees. Now, in the warm-up that we had today is the tool with which I'm going over this. Now, in front of you, you will see that we have a polynomial, and I've actually separated the 7 sine theta into 4 plus 3 sine theta so that we can factor by regrouping. Now, when we're trying to factor by regrouping in this problem, be aware that as I look at this, I want to factor out the same thing from both sides and try to have what remains to be equivalent. But notice that we have a 3 here and a root 3 here. That means that in order for me to do this, I'm going to have to factor out a root 3. Here, I can factor out a 2 and the sine theta. So I'm going to have 2 sine theta, and it's going to leave me with root 3 sine of theta, and then I have plus 2. From this, I'm going to factor out a positive root 3, and I'm left with root 3 sine theta plus 2 equals 0. I can now see that they both have a GCF, so I can factor out that greatest common factor, leaving me with 2 sine theta plus root 3 times root 3 sine theta plus 2. Now in our warm-up today, we then went from our solving, which allowed us to take each of these factors, and by our zero property, we know that we're going to have to set each one equal to root 3. So I'm going to set the first one equal to root 3, and I'm going to set the second one equal to 0, and then root 3 sine theta plus 2 equal to 0 by the zero property. Now this allows me to solve so that I get sine of theta is equal to negative root 3 over 2, and the sine of theta is equal to negative 2 over root 3. Now, you might want to recall that when we were solving before, we always had to check for extraneous values. Now, when we're talking about the unit circle, we're saying that all of the values have to be within the range of a sine function for this. And in this one, our sine function is only between negative 1 and 1, and we're looking at something that is a lot more than that, which means that this is an extraneous piece, and there is no solution when we're trying to find the sine of theta is negative 2 over root 3. But we know that root 3 over 2 is our reference angle of theta equaling pi over 3, and that's theta prime. And our answers are in the third and fourth quadrant, and that requires us to think about what do we do to find theta in the third quadrant. Well, to find theta in the third quadrant in radian mode, we take pi plus the reference angle. Now, you might want to just take a moment and recall that the reference angle is always an angle that is a length or a measure, and therefore it's an absolute value. And it always sits between the terminal angle, or terminal side of our angle, and the x-axis. So you'll notice in all three quadrants, they form vertical angles. Remember how vertical angles are congruent in your geometry? Well, we're looking at vertical angles here, all right, from quadrant 2 to quadrant 4 and quadrant 3 to quadrant 1. And then you need to remember that in quadrant 1, theta prime is theta because of the way we draw our angle. Unfortunately, in our second quadrant, it's not the case because we have pi and our angle is sitting right here. See, this is our angle right here. So we're going to take in the second quadrant, we're going to say that theta has to be pi minus the reference angle. And then when we go into the third quadrant, notice we went past pi by theta. That means in the third quadrant, we're talking about our angle is going to be pi plus theta prime. And since 2 pi is here, our angle is this great big angle going all the way to here. And that means we have to take away theta prime from 2 pi in the fourth quadrant to find theta. Now this is something you have to memorize. And if you choose not to memorize it, I'm going to be sorely hard-pressed to figure out how to help you, because these are the basics, just like our ratios. Please remember, you've got to learn your ratios. You have to learn your fundamental identities. You also have to learn how to find the reference angle, as well as how to use the reference angle in the first, second, third, and fourth quadrant. And that's what we've been doing every time we've used our calculators and the arcs in order to figure out those non-standard angles. So let's just go ahead and use it now. In the third quadrant, we're going to take pi and add it to pi over 3. We're going to get 4 pi over 3. And in the fourth quadrant, we're going to take pi over 3 from 2 pi, and that's going to give us 5 pi over 3. In addition to our no solution, we can now see that there are simply 2 answers. Okay? And that was the first problem in our warm-up. In a moment, I will go over the second problem. Once again, still solving, but this time we're going to be doing it in degree mode. Thank you very much, Hornets. I hope this was useful, and if it was, please click like. Thank you. Bye-bye. Cheers.